All right, I wanted to have an opportunity to go over this SGO. These questions might be out of order from the way you saw them, but there is some need to talk about different ones, so I'll try to point them out. All right, in this one, when you try to plug in 0, the ln of 4 minus ln of 4 is 0 over 0. So because of that, you can use L'Hopital's rule and do the limit of the derivative over the derivative. Now, the derivative of the ln of 4 plus h is 1 over 4 plus h. The derivative of ln of 4 is 0 because ln of 4 is a number, and the derivative of h is 1. So now when I plug in 0, I should get 1/4. Here we were doing right-hand sums. So remember, if you're doing a right-hand sum, you're dropping the first item. And so you're doing a distance of 7 with a height of 12, a distance of 5 with a height of 5, and a distance of 3 with a height of 1. So, and you can't forget that you did start with 50 liters. So it should be 7 times 12. Where's that one? 5 times 5. Right? So that would be B in my case. Okay, this says what is the acceleration. So if you have velocity, the acceleration is the derivative of velocity. So the derivative of the sine of something is the cosine of the something, and then the derivative of the inside is pi over 3. So the acceleration at 1, you're just plugging the 1 in there. So whatever the cosine of pi over 3 is, that's the cosine of 60, which is the 1/2. So we have pi over 3 times 1. Cosine of 60 is 1/2. And so that final answer is pi over 6. This one, the limit as x approaches 2 is 2, because from the left and the right, it's approaching 2. It doesn't have to actually equal the plottable point. This is the one most everybody got correct. I know it was something, it's really only the first step in terms of if we wanted to find critical points, but most everybody got that correct, I believe. With the product rules, derivative of the first times the second plus first times derivative of the second, and the derivative of the second had that chain rule. All right, now, number 6 here is talking about when is a function increasing. A function is increasing when its derivative is positive. So the derivative of this is positive. It looks like the derivative is right here, right? Yeah, and there's positive. So again, this is a first step to solving. What you really would have to do is now know how to solve this quadratic inequality. And remember, you could set it equal to 0 and figure out where it equals 0, and then you have to test regions to see where it's greater than 0. So quadratic inequalities is something you'll work on right away next year in a calc program. Number 7 is the one most everybody got correct. Number 8, it was just the wording. Mean value theorem is there's a point between A and B that has the same slope as the secant line. Okay. So, and the ordered pairs are written A, F of A. Right, there you go. And B, F of B. So, again, for any 2 points, there's some point in between them that has the same exact slope as the secant line. This is also the one that almost everybody got correct. Factoring and then plugging in the 4. This one actually some people did mess up. The limit at 4 from the left and the right are not the same, so you must say does not exist. Don't forget that. F of 4 is a plottable point, but the limit from the left and right do not equal each other, so the limit does not exist. Doing product rule here, most everybody got this one correct as well. The implicit didn't go too bad. Derivative with respect to x Now, when you do this product, derivative of the first times the second plus the first times the derivative of the second. So when you solve for dy dx, you have a negative 2 and a negative 3y divided by 3x. So I did see a few of you, rather than picking the opposite answers to both the numerator and the denominator, which is what d is compared to what I wrote, some of you did try to pick A, but that's not correct because the 3y would have to have also been negative. Okay, so with this question, you do really need to see, let's see. You need to really know what the graph looks like because that's the easiest way to do it. Obviously, you can do it different ways, okay? But the easiest way to do it is to remember sine normally has a period of 2 pi, but 2 pi over the coefficient tells you the new period is 6. And sine without any translations up or down pretty much looks like that. So this must be a 3 and this must be a 1.5, right? Because the end is a 6. So since speed is the absolute value, wherever velocity is below the x-axis, speed would be above the x-axis. All right, so now the speed graph is drawn because it's the absolute value of velocity. So speed is increasing from 0 to 1.5 and from 3 to 4.5. That's really the easiest way to see that speed is increasing because the numbers are getting larger. And if you had looked at the velocity graph down here, they were getting more negative. So that is a way to see also possibly if velocity is getting more negative, that does mean the speed itself is increasing. All right, so that one ended up being 0 to 1.5 and 3 to 4.5. All right, and the last two, given the sketch of f prime, when would the original be concave down? So I remember concave down is when the second derivative is negative. So to me, the only way the second derivative is negative is if the first derivative is decreasing. Remember, there's such a big difference between the word decreasing and negative. So where this function is decreasing from 5 to 15. And finally, the changing direction question. You're changing direction when velocity goes from positive to negative. So you are, or negative to positive. So you are still using the same graph. It does want to go all the way to 12. So being mindful exactly what's in the middle of each period. So changing direction, of course, you're going from either positive to negative or negative to positive velocities. So I do believe the answer was there. Okay? So that was to show you what I felt the answers were. Let me know if you